You can also write the fraction 1/3 as a decimal using long division because 1/3 means 1 divided by 3. Here's an example. 1/3 equals 1 divided by 3. Note we have some 0 placeholders here already written in green. 3 goes into 1 0 times, and 3 goes into 10, not forgetting our decimal point. 3 goes into 10 3 times, subtracting 9 from 10. We arrive at 1, dropping down the next 0. Note we already took away 9 from 10, so even though I don't have things lined up very carefully, I was careful when dropping down the next 0, and 3 goes into 10. That seems familiar. 3 times. 3 times 3 is 9, so we subtract 9 from 10 once again. 1. Drop down another 0. 10. 3 goes into 10 3 times. 3 times 3 minus 9. We need some more zeros. 0, 0, 0. Continuing. 3. We have to make this line longer as well. All right. 1, 0. 3, 1, 0, 3, 1, 0. More zeros. Extend the line. Back to blue. 3, 9, 1, 0. 3, 9, 1, 0. 3, 9. Boy, maybe we should have recognized this was repeating earlier. 0.333. Right away, we notice a pattern. This could be written as 0.3, about here, 0.3 with a bar over the top. That means 0.333, and the pattern continues. Both adequate ways to represent this 0.333333 indefinitely. And example problem 6. Use long division or a calculator to write rational numbers as repeating decimals. Write each rational number as a repeating decimal. Use long division for A and B. Use a calculator for C and D. A and B, so 1 divided by 11 can be written as 1 divided by 11. Some zeros. 11 goes into 1, 0 times. Decimal point. 11 goes into 10, 0 times. 11 goes into 100. Well, 11 times 10 is 110. So we must be considering 1 less than 10 times, so 9 times. 9 times 11, 99. Subtracting 99 from 100, we're left with 1. 0, 0. We drop down the next 0. 11 goes into 10, 0 times. Drop down the next 0. 11 goes into 100, 9 times. And we immediately, well, almost immediately, have hit a pattern, a repetition of 0.090909. So we've found this pattern. Let me complete this. 9 times 11, 99. So rather than continuing all day long, because, you know, let's write it this way. 0.09 with a bar over the 0 and the 9. Part B, 13 twelfths. Can be written as 13 divided by 12. Adding some zeros here, since I recognize there will be a need for those. 12 goes into 1, 0 times. 12 goes into 13, 1 time. 1 times 12, 12. 13 minus 12, 1. Make sure the decimal point lines up here. Drop down a 0. 12 goes into 10, 0 times. Drop down another 0. 12 goes into 100. Well, 12 times 10 is 120. 12 times 9 would be 12 less than that. 12 times 8. Well, 12 times 8 over here on scratch paper. 8 times 2, 16. 8 times 1, 8 plus 1, 9. 96. So subtracting 96 now. A difference of 4. The next 0. 12 goes into 40. Well, 12 goes into 48 4 times, so 3 times. 12 times 3, 36. And see what's going to happen? A 4. That looks familiar from the previous step. Dropping down a 0, 40. Dropping down a 0, 40. 12 goes into 40. Well, 3 times again without going over. Subtracting 36. And another 4. So here's our repetition. 3, 3, 3, and a few dots. Or, using the notation, 13 over 12 equals 1.083 with a bar over the 3. And recall, problems C and D, we're told that we can use a calculator. Now, a basic 4-function calculator will do just fine, but I'm going to use my graphing calculator. 82 divided by 333. 82 divided by 333. 0 point, and note my calculator doesn't put the 0 placeholder in the ones place. I'm going to. 0.246, 246, 246. So there's a repeating pattern. I'm going to go back to red here for consistency, and I'm going to write that 82 over 333 is equivalent to 0.246. And now the bar will go over the 2, the 4, and the 6 to represent that those 3 will repeat indefinitely. Clearing my calculator for the next problem, 2 divided by 7. 0.2857142857. I see the repetition. So once again, red pen, D 2/7 equals 0.285714. All of those with a bar over the top.